Now, in this question, we've been given that a train traveled at 1/3 of its usual speed and hence reached the destination 30 minutes after the scheduled time. On the return journey, it traveled at usual speed for 5 minutes, but then stopped for 4 minutes for an emergency. Then the percentage by which the train must now increase the usual speed, so as to reach the destination at the scheduled time, is closest to which value? Now, of course, the bad method would be to take variables and to form equations and all of that. We are not even going to get into all of that, because clearly the only thing we've been given here is times. And we have, of course, some information about speed as well. But we don't really have any actual value. We don't know the actual speed. We don't know the actual time. We don't know the actual distance. So no point taking a whole bunch of variables and forming equations. What we'll do is, we'll focus on the fact that the distances are the same. Okay, the train is always traveling the same distance. It's always traveling the same journey. Because whatever it is traveling, return journey will be the same distance. So if the distances are the same, we can look at the ratio of the speed and time. Okay, so if we look at the ratio of the speed for the usual situation and for the new situation, usually whatever is the speed in the new situation, it is 1/3 of that. 1/3 with 3 in the denominator. So if we take the usual speed to be 3 in the ratio, the new speed will be 1/3 of that, so that will be 1 in the ratio. So this is the ratio of the speed, which means ratio of the time will be the reverse, 1 reciprocal, 1:3. And now we have information about this, that in this case, because the speed became 1/3, the train reached the destination 30 minutes after the scheduled time. So it took 30 minutes more compared to usual. So if you look at the ratio of the time, 1 and 3, we have a gap of 2. Which means as per the ratio, usually if it takes 1 part of time, now it is taking 3 parts of time. So it is taking 2 more parts of time. 2 more. And we also have 30 minutes more. So we can say here that the 2 parts more that we have, that is equivalent to 30 minutes more that we have. Now if 2 parts is 30 minutes, then the 1 part that we have here will be half of that. So that will be 15 minutes. So we can say that the usual time is 15 minutes. And of course, we should focus on that because we are focused on usual speed for the question. So we look at the usual time. Now, what is happening on one day is that on the return journey is that the train is traveling at usual speed for 5 minutes and then stopping for 4 minutes. Now, suppose it had not stopped. Okay, suppose it had traveled at the usual speed for 5 minutes and not stopped. Then it would have just been the usual situation, 5 minutes, and then the train would have needed another 10 minutes. And then the train would have reached on time because the total time we need is 15 minutes in the usual situation. So for the remaining part of the journey, the train would have taken 10 minutes, usually. Now what is happening is, the train, it's not actually taking 5 minutes for this part of the journey, for this distance. It's taking 5 plus 4. See, it is taking 5 minutes to cover the same distance. Then it is stopping for 4 minutes. 4 minutes, it's not moving at all. So for the same distance which it usually covers in 5 minutes, it is now taking 5 plus 4, 9 minutes. But we still wanted to reach at the scheduled time. So we still wanted to take 15 minutes in total. So 15 and 9, the difference is 6. So we wanted to take 6 minutes now for the remaining distance. So usually the distance that it takes 10 minutes for, now it has to cover it in 6 minutes. Now, if you look at the ratio of these times for the same distance, for the same remaining distance, the ratio of the time is 10:6. So the ratio of the speed, of course, will be the reverse. Ratio of the speed will come out to be 6:10. And 6:10, of course, we can simplify. So that will become 3:5. And now we just have to find the percentage increase in the speed. So now from 3 to 5, the increase is of 2. So we have increase of 2 upon the original value of 3. So 2 by 3, that gives us 66.67%. And that is there, of course, in the second option. Okay, so here we just had to keep in mind that if the distances are the same, we should focus on the ratio. One of the most basic and important concepts in this topic. And after that, we just had to solve the question logically. So now try out the replica question that we have using this method and let us know your answer in the comment section.